All right, so let's get started with NAT. What does NAT allow us the ability to do? Translates private IPs to public IPs to conserve public IPs. All right. Now, the way dynamic NAT works, we create a pool of public IPs. You link it to internal addresses that can use the pool of public IPs, and the internal device tries to go out. It picks an unused IP address from the pool and translates it. It keeps the translation in a table known as the translation table. When the packet returns, the IP, the destination IP, gets untranslated back to the original IP and is sent back to the original device. All right. This is the verbiage behind it. Now, what happens over here? Actually, I have a diagram over here that will illustrate that. I'll just use that as an example. I have an internal PC whose IP address is 10.10.10.99, wants to go to the internet to this public address, 150.550.555. Everybody okay with that so far? This PC will send its packet to its default gateway, which is router 1. Still an internal device. He will forward the packet to the default gateway, which is the ASA firewall. ASA firewall gets this packet. It has a public pool that I've created over here of 192.1.20.51 through 200. So roughly it has 150 public addresses. Following so far? And I've specified that the internal address of 10.10.10.20.20 can use this pool. So because I've specified that, what it's going to do with the packet, it's going to take this packet, which was 10.20.20.99, change that address to a translated address, picks an address from the pool, and it randomly picks an address. It has picked up 192.1.20.75. Sends it across to the internet through the default gateway, goes to the internet. He gets it. He gets a packet like this. 192.1.20.75 destined to 150.555. The device gets it. He will respond back. When he responds back, he flips the source and destination IP now. 150.555 is the source. 20.75 is the destination. Sends it back over here. Gets sent over here. Now in the translation table on the firewall, it would have kept the entry that says that 10, 20, 20, 99 has been translated to 192.1.20.75. And once he gets a packet, it will retranslate the packet back down to what? 150, 555, 10, 20, 20, 99, sends it back to the original source. Everybody okay with that? So on the way out, it gets translated. On the way back in, it gets untranslated. So any packet that gets translated, for it to come back to the original device, needs to be untranslated. You will never have one-way translation. If you have one-way translation, the return packet does not get untranslated back to the source. It doesn't know where the source is. So when the packet went out, it went out like this. Oops. $10, $20, $20, $99, destined to 155.55. At the end, when it comes back, it will have flipped the source and destination, but it will keep those same addresses, just flip them. So 10, 20, 20, 99 goes to 155.55. Return is coming from 155.55 to 10, 20, 20, 99. Everybody okay with that? Yeah? There? Now, the other thing that I want you guys to understand over here as well that we don't pay so much attention to, in this translation, what is getting translated? Is it the source or the destination? Source? Just the source? Take a look. From in to out, the source got translated to what? To a public address. So went from 10, 20, 99 to 192.1.20.75. On the return, what happened? 192.1.20.75 got untranslated to 10, 20, 20, 99. You get my point? So in to out, the source got translated. Out to in, the destination got translated. Do you see that? Everybody okay with that? So depending on the direction of the traffic, from in to out, the source got translated. Out to in, the destination got translated. Good? The other thing, well, generally speaking, you either going to either way you look at it, whether it's traffic from in to out or out to in, you are going to translate yourselves, Marvin. You're not going to translate source and destination at the same time. Let me explain that. When you point to the internet, to point to to some server on the internet, what address do you use over there? You use their public address, right? You go to google.com, you go to facebook.com, you're using their public address, correct? From your perspective, I'm not talking about what they're doing. I'm talking about from your perspective, right? You're going to point to 50555. Did that get translated over here? No. It went to the internet. It went to that device. I don't know what happened behind their firewall. From my perspective, I sent it to 50.555. Return packet coming in from 50.555, 5555, 5555. It didn't get translated at all. That's very specific. Normally you go to the internet, right? And what you're talking about where you have both having overlapping subnets, that is a very specific case. When you say in general, only one translation happens. You get my point, Marvin? Your case is a one-off type of thing. Generally, this is what's happening. Agreed? So now what I want you guys to understand is you will face terminology where they talk about source NAT and destination NAT. This gets very confusing. When you look at source NAT, I don't want you guys to think about source NAT being the NATing of the source IP address in the packet. The word source means local IP. So if you're translating your local IP, whether the local IP happens to be in the source part of the header or the destination part of the header, it is called source NAT. Okay? On a router, they refer to as inside NAT. We're not doing a router, but just because you brought it up, Kevin, that's why I specified it as inside NAT. Kern, this is an example of what I just did. Take a look at what IP address is getting translated, your address or their address. The reds are the translations. Whose address is getting translated? Your address is getting translated, isn't it? Is their address getting translated? So whenever your address is getting translated, their address is not, which is 99% of the time. Whenever you point to google.com, you point to google.com's public address, facebook.com, microsoft.com, cisco.com, you point to their public address. Their address will remain the same in the life cycle of this packet. They're not getting translated. Who's getting translated on your firewall? Your address is getting translated from the local to the public, and on the return, your public is getting translated to your private. But your address is getting translated. That's an example of source NAT. So 99% of the time, you're doing source NAT. Absolutely correct, Kern. Absolutely. Why? The source NAT is not where are you changing the source address or the destination address. The word source refers to your address getting translated. Got it? So everybody okay with that? NAT or PAT doesn't matter. You're changing your address, it's source NAT or source PAT. What is destination NAT then? As I said, 99% of the time you're going to do source NAT. In those one-off type of situations where you do want to change their address meaning the remote address. Marvin gave an example of that. That is where you have overlapping subnets, you're doing a VPN. So in that case, you're changing their address, the remote address. That's where that's what it's called, destination NAT. No, Doug, it does not have anything with the initiator. I'll get to that in a second when we do static NAT. Has nothing to do with the initiator. It's whether your address is getting translated or not. Whether you initiated it or they initiated it, that doesn't matter. So if in a case that you are changing their address anywhere, that is the 150 address in our case, if that address was changing, then it would be called destination NAT. The word destination refers to the remote address or the foreign address. Hang in there, Doug. When we do static NAT, I'll show you that. So if I'm changing their address, it's called destination NAT. So majority of the time, you're going to be doing source NAT. Understood. Why source NAT? What does the source mean? Again, I want you guys to make sure you understand that. Source NAT means that your address is getting translated. Whether that your address is in the source part of the packet or the destination part of the packet, that is not important. What is important is your address is getting translated. If your address is getting translated, it is called source NAT. Very seldom do you change or translate their address, the remote address. If you do, it's called destination NAT. I'll show you an example of that as well, but for right now, I'm focusing on source NAT. Good so far. So how does dynamic NAT work? In dynamic NAT, you would create a pool of public addresses over here. Let's say 192.1.20.51 through 192.1.20.200. I will specify who is allowed to use that address. So let's say I'd say I want to allow 10.11.11.0 to be able to use the pool. So when they initiate the traffic from here towards the outside, their address will be changed from what? 10.11.11.0 or whatever the address is to one of the addresses in the pool. From in to out, it will change the source part of the packet, source field. But on the return, now I'll be coming back with the destination of the remote address as a source, and then your translated address will be in the destination. On the way back, it will get returned back to what? 10.11.11.0 from whatever the translation was. Out to in, it will change the destination field, but it's still called source NAT because the only field that is changing is your field. Clear on that? Dynamic NAT, another thing about dynamic NAT. It is generally configured to allow internal devices going towards the internet. Okay, that's what dynamic NAT is used for. Now, how do I do this? How do I configure it? Configuration part of it. I'll create an object, configure a pool of public IP addresses. The way you do that, object network, give it a name, whatever you want to call it, pool A. The way you define it is by using the range command. Everybody okay with creating the pool? This is how you create a pool on a ASA firewall. Specify the NAT statement to mention or to link the internal network that is allowed to use the pool. How do I do it? Again, another object for that. Whatever you want to call it inside, I'll just give it a name, net 10.11.11.0. That's just a name. The way you specify it, 10.11.11.0. NAT, the high interface first, followed by the low interface, the two interfaces involved in the NAT, dynamic, and the name of the pool. So what it's doing, in a simple explanation, I'm basically allowing traffic initiated from what? Inside using this address to go outside. When it goes outside, it will change the address on the outside interface to the address based on the pool. That's what it's doing. There are different names for it. Yes, it is called Object NAT. Object NAT is because I am using objects to define the NAT. Okay. This is also referred to as Auto NAT. The more technical term for it is Auto NAT. And in terms of what it's accomplishing, it's called Dynamic NAT. All three are good. All three are right. So you can call it Object NAT. It is also referred to as Auto NAT. It is also referred to as Dynamic NAT. All of them are good. Good so far, guys? Can you do a show command to verify one specific NAT? The actual translation or the NAT command? Show translate, show xlate. Not a specific one, but it'll show you the translation table. Then you need to filter if you want to take a look at it. You guys okay with this? Ready to configure this? Copy it. We'll go to the ASA firewall and paste it. It doesn't like the space. Space sensitive. My translation is done. To see if the translation was done, NAT show NAT detail tells me that in to out, traffic is going from inside to outside. Source, based on this, the origin, 10.11.11.0 will be translated to this guy. All right, everybody okay with that? Clear, everybody? Let's see if it works. Now that I've translated it, I've specified that 10.11.11 should get translated. So if I go to router 1, which is on the inside, and I do a telnet to 199.111, it should get translated to an address from that range. Let's try it again. There you go. I'm in. Show users. It'll tell me that the user that's connected in is 20.195. So it picks a random address from that pool. You can check the translation over here. Show xlate. 10.11.11.1, which was the inside device, was translated to 20.95. It has done dynamic NAT. Everybody okay with that? All right. So that is dynamic NAT. When is dynamic NAT used? When its traffic is going from, generally going from inside to the outside. Clear so far? And the syntax, 99% of the time, I'm not going to say it's all the time, but 99% of the time, if I had to write it, it would be like this. I'll give you a syntax for this as well. So if you want to change it later on, network, I'll say inside brackets, inside just a name, whatever you want to call it. Subnet is going to be the inside network. in terms of the interfaces, high, low. What do I mean by high, low? The security level. Okay. I had two interfaces involved in this translation. Traffic going from in to out, inside to outside. What is the security level of inside? 100. Outside is 0, right? So when you write the name, you write the high first, generally, 99% of the time. I'll give a more detailed explanation later on once you have a comfort level with it. But right now, high means what? Inside first, and low next, which is outside. The pool goes over here, the inside network goes over. Good so far?